The fourth category is removable modem. Modem used with the older laptops, that is PCMCIA port or input output devices that directly connects to a personal computer or the laptop or the computers. These slots and can be added or removed as needed. So what it means, we have a slots within our system. If we required the modem, then we can simply insert the modem to with our system, and whenever a work is done, we can simply remove that modem from our system. So this type of modem is known as the removable modem, means we can remove at any time. Clear? Okay. So next is the transmission. The next topic, that is, it is called the transmission. The first is the serial transmission, and the second one is parallel transmission. We have the two different types of transmission. Before going to this topic, we know the meaning of the transmission. Transmission means whenever I am sending data, either it uses a serial transmission or it uses the parallel transmission. Transmission means the mode of data from which the data is moving from sender to the receiver. We have the two different concepts. The first one is the serial transmission. In the serial transmission, data bits flows from one computer to the another computer in a bi-direction. In this transmission, one bit flows at one clock pulse. In serial transmission, 8 bits are transferred at a time, having a start and stop. So, what it means in the serial transmission, the first thing is the data can be moved from sender to the receiver in a serial form. Serial form means, the best example is, you have the number of books are there. You have the number of books along with you. The you can write, you can see the page number on the books. This is a serial form. Serial form means, first the page number 1 is coming, then 2, then 3, then 4, then 5, then 6. Suppose if your book has a 500 pages, the numbering of the pages from 1 to 500 means in a serial order. Clear? This is called the serial transmission. When a bit by bit is sent or data is sent one after the other in this form, this is called the serial transmission. Now look at the diagram. The computer 1 is there. They can place the computer 1. This is the computer 2, and they can send the data. Now sending the data means they are sending the data in the form of zeros and 1. So what it means, the first bit that is sent is 1. 1 followed by the 0, followed by again 0, then 1, then 1, then 0, then 0, then 1. So what it means, the data can be transmitted from sender to receiver in the form of serialization, one after the other. This is called the serial transmission. Clear? The next is the parallel transmission. What is parallel? Parallel means the number of bits they can send simultaneously from a single system towards to a other system. What it means, the number of bits are same as used in the serial transmission. Look at there, these are the bits are same, the 1 0 0 1 1 0 0 1, but the difference is in the parallel transmission, all the 1 2 3 4 5 6 7 8, all the 8 bits, they are sending simultaneously at the same time. This is called the parallel transmission. Clear? In parallel transmission, many bits are flowed together simultaneously from one computer to the another computer. The parallel transmission is faster than a serial to transmit the bits. Parallel transmission is used for short distances. Whenever we are sending the number of bits at the same time, it is called the parallel transmission. And the parallel transmission is faster than serial. How faster? Because suppose it required a 1 second for one bit to send. We have the 1, 2, 3, 4, 5, 6, 7, 8. I am sending, suppose the computer 1 here I am, and the computer 1, computer 2, you are at their side. What it means, I am going to send the 8 different bits. So what it means, one bit contain the 1 second, 8 bit required 8 seconds. I required 8 seconds to send the 8 bits towards you. Total transmission time is 8 seconds. But in the case of parallel transmission, we are sending all the 8 bits simultaneously. So what it means, only a single second is required to send the 8 bits. Clear? The transmission is parallel. Next we have the modes. Modes means the data modes are there. In which mode we are sending the data? The first one is synchronous modem. The first one is the synchronous transmission, and the second one is asynchronous. And whenever we are sending the data, we are sending in which mode, that depends, either the synchronous or the asynchronous. But the data traveled through the modem, so we have either the synchronous modem or asynchronous modem. Now let's start the discussing the synchronous and asynchronous. What are the differences, and what is the definition of synchronous, and what is the definition of asynchronous? Now let's start with the synchronous modem. The data is transmitted in frames along with the synchronous bits, which are used for ensuring the timely transmission and reception of data. These modems are mainly employed on the dedicated leased lines. Basically, the synchronous modem, they ensure the synchronization of the bits. You also have a option of synchronization in your cell phones. What is the meaning of synchronization? Means they can sync means they can be collaborative the data along with this application. This is called the sync. So synchronous bits means the all the bits, they are in the form of synchronization, and they are mainly employed, or employed means, or they are mainly sending on the dedicated leased lines. Dedicated line means whenever a dedicated connection is made between the sender and the receiver, or dedicated means whenever there is a single connection between the sender and the receiver. We have the two systems. I can add the wire from one system one to system 2. What it means, now they are connected through that wire, so this is the dedicated connection. Clear? Synchronous modem does not use start and stop bit. No start bit is there, no stop bit is there. There is no gap between the various bits in a data stream. No gap. What it means, the continuously the bits are sending in the form of synchronous modem. No start and stop is there. Continuously they sends the data. Suppose if you are sending the data in the form of bits of zeros and one, so what it means, in the case of synchronous modem, the data is 11010100000101 continuously, in the continuous form. Clear? In order to receive the data error free, the receiver and sender operates at the same clock frequency. Operates at the same clock frequency. What it means, clock frequency means, suppose I am sending data, you are receiving the data. I required a 1 second to send a single bit. You also required a 1 second to receive a single bit. So what it means, after the completion of 10 seconds, I am able to send the 10 bits. Also, you are able to receive the 10 bits after the end of 10 seconds. So this is called the clock frequency. What it means, after every second, I am sending data. You are at the receiver side. After every second, you are receiving a data. So this is called the clock frequency. Clear? Now look at the diagram, the synchronous transmission. A sender is there. Suppose I am the sender, a receiver. You all are the receivers. This is the direction of flow. Direction of flow means always the direction is from sender to receiver. If I am sending data, the direction is always at towards your side. And now this is a synchronous transmission. The two main important things are, the first is no gap is there. As you discussed, as we discussed in the last slide, the first is no gap is there, and second is no start and stop is there. Now look at the data. This is the data. Any gap is there? No, no gap is there. 0 1 1 0 0 0 0 1 0 0 1. The packet is finished, the frame is finished. again next frame is start, then next frame, then next frame, then next frame. So one thing is clear, no gap is there. Second, no start and stop is there, only the continuous flow of data. The stream of bits, they are in the continuous form. This can be happened in the form of synchronous transmission. Now the second, that is completely different from the synchronous, and the name is asynchronous modem. And this in these types of modems, every byte is positioned between a stop and start bit. Now the new concept is there in the case of asynchronous. Whenever, suppose I am the sender, whenever I am going to send any data, I used the start bit at the start and used the stop bit at whenever a data is complete. Now with the help of start and stop, the receiver can come to know whenever a data is start, whenever a start bit is there, that stream of data is start. Whenever a stop bit is there, the data is completed. That can be happened in the case of asynchronous modem. This lacks the timing signals or clock between modem and the DTE, that is called data terminal equipment, the number of equipment that are used to transfer the data. But the problem is there, the clock frequency or the clock signals not remains the same, because the number of time that is wastage by using the start and the stop bit. Clear? It is able to manage a continuous flow of data between bits, provided that a clock signal is used. Bit synchronization between the two devices is made possible using the start and the stop bit. Start bit indicate the beginning of the data, as we discussed. A start bit is usually a zero is added to the beginning of each byte. Stop bit is indicates the end of the data. Usually ones are called the stop bit. Now the difference from the synchronous to the asynchronous is, the one concept is here. That concept is they are using the start bit and the stop bit. Now look at the diagram. Look at here. The sender is there. Suppose I am the sender, a receiver. You all are the receiver. Clear? The two things that can't be happened in the case of synchronous. The first thing is no gap is there, but in this case the gaps are there. Look at the gaps between the data unit. Look at this. Whenever a data unit is completed, a small gap is there. Then again the data unit, again gap is there. Then data unit, then gap is there. The first thing that is different. Second thing that in the synchronous is no start and stop. But in the case of asynchronous, we have the two bits, the start bit and the stop bit. And always, whenever a data unit is start, it start with zero. Zero represents the start bit, and whenever a data is completed, we have another bit at the end of our data unit is called the stop bit, and stop bit can be denotes with the help of 1. So what it means, now your data units, they start with the 0, that is called the start bit, and end at the 1, that is called the stop bit. The stop bit is there, look at your screens, the 1 is there, this is called the stop bit. The 0 is there, this is called the start bit, and the number of gaps are there. These are the two main differences that can be happened between the synchronous and asynchronous mode. Clear? Next, the next is the transmission mode. Now we can transmit the data. Suppose I want to transmit the data towards you. We have the three different modes by we can communicate with each other. This is also called a communication mode. Suppose we want to communicate with each other. In which mode we are communicating? For this we have the three different modes. Transmission mode refers to the mechanism of transferring of data between the two devices connected over a network. It is also called a communication mode. These modes direct the direction of the flow of information, and there are three different types of transmission mode. So what they said it is also called a communication mode, and in which flow we are communicating with each other, that also be decided by the communication mode. And we have the three different modes. Three different communication modes are there. The first, simplex mode. Second, half duplex mode. Third is full duplex mode. We have the three different modes. Now we are discussing one by one all the three modes. Now first one is, okay, the diagram is there. First we can discuss it with the help of diagram. Look at here, the simplex. The first is simplex, mainframe or monitor. Mainframe means a system, or you can say the two systems are there which they want to communicate. But the difference is, look at the arrow, the direction of data. So what it means, in the case of simplex mode, the mode of the direction of the data is one way only. In this diagram, the mainframe can send the data to the monitor, but monitor cannot send the data to the mainframe. An example is, we have a computers in our homes, we have a CPU, we have a monitors. Always the data that is displayed on the monitor is given by the CPU, but no data is going back from this monitor to the CPU. Clear? What it means, the flow of the direction is one way. One way means only mainframe can send the data to the monitor. No data is received from the monitor to mainframe, or the monitor is not able to send in even a single bit towards to mainframe. Clear? Second, half duplex. Look at there, the half duplex. Workstation means the system. Workstation, direction of data at time t1. Time 1 is from first workstation to the second workstation, and downwards, direction of data at time 2, from second workstation to the first workstation. What it means, now in the case of half duplex, both the systems can communicate with each other. Both can send the data, both can receive the data. But the thing is, at the same time, only one system can send the data, other can receive the data. At the second time, that other system can send the data, and this main system can receive the data. The best example is walkie talkie. Walkie talkie handsets are there. First we can talk on that walkie talkie, and after uh, our talk is complete, then we hear the voice from comes out from the walkie talkie. What it means, at the same time, only the single system is able to send the data. At the time t1, if system number 1 sends the data, system 2 only receives the data. At time t2, if system 2 sends the data, only the system 1 only receives the data. That can be happen in the case of half duplex. Clear? The next is the full duplex. In this case, first you can check the arrow is there, the direction is as the both side. Look at this, arrow is there, also the arrow is there, direction of the data all the time. What it means, in the case of full duplex, both the systems, they can receive and sends the data at the same time. The best example is cell phones. At the same time, we can speak or we can hear, either sender side or the receiver side. Clear? So these are the three different modes. Now with the help of definition, we are going to clear the concept of simplex, half duplex and full duplex. The first is simplex mode. In this type of transmission mode, data can be sent only in one direction, as shown in the diagram. Look at here, data can be sent in the only one direction. Communication is unidirectional. Uni means one directional. We cannot send a message back to the sender. Look at here, only the mainframe can send the data to the monitor is not able to send the data to the mainframe. Only one system is able to send the data. Unidirectional communication is done in the simplex system, where we just need to send a command or a signal and do not expect any response back. No response is coming back in the case of simplex. One thing is important, the transmission is unidirectional. Second thing, we cannot send the message back to the system. And third one is, no response is expected in this case. Clear? Examples of the simplex modes are loudspeakers, television broadcasting, television and remote, keyboard and monitor. The best example is keyboard. You can type the message on your systems. We simply give the input to your system, but then nothing is coming from that keyboards to your side. This is called the simplex mode. Clear? Now the next diagram is sender one. This is sender, receiver. This is a device one, device two. Direction of flow all the time, at all time. At all time, whenever a communication is held, the direction of the data is unidirectional. Only in this case, device one is able to send the data to the device two, but device two cannot send the data towards to the device one. This is called simplex mode. Second, half duplex mode. The half duplex data transmission means that data can be transmitted in both directions. The sender device 1 can send to the device 2 can send to the device 1 on a signal carrier, but the difference is but not at the same time. But both are not able to send the data at the same time. Both are able to send the data but on a different time. For example, at the time t1, system 1 is sends the data, system 2 receives the data. At time t2, system 2 sends the data, system 1 receives the data. They both can send and receive the data but on a different time. Clear? So we have a small example is there on a local area network using a technology that has half duplex transmission. One workstation can send on the line and then immediately receives data on the line from same direction in which data was just transmitted. Hence, half duplex transmission implies a bidirectional line, but data can be sent in only one direction at the same time. This example also shows the only the one thing that that might be clear in your mind. In the case of half duplex, both the system can send and receive the data, but they are not able to send simultaneously. Clear? Example of half duplex is walkie talkie, in which message is sent once at the time, but message are sent in both the directions, are not sent in the both the directions. Clear? And not at the same time. You can send the data, you can receive the data, but at the same time you are not able to send and receive the data in the case of both the devices. Clear? This is all about the half duplex. And look at the diagram. In the diagram, now the one thing, the device 1 is there, device 2 is there. At t1, device 1 is sender, direction of flow at t1. At t1, devices 1 is sender, device 2 is the receiver. What it means, device 1 sends the data, device 2 receives the data, but same time at the next time t2, device 1 becomes the receiver and device 2 becomes the sender. So what it means, device 1 it is also a sender, it is also a receiver. Same in the case of device 2, it is also a sender, it is also a receiver, but the difference is it becomes the sender and receiver at the different times. Clear? Now the next is the full duplex mode. In full duplex systems, we can send data in both the directions as it is bidirectional at the same time. In other words, data can be sent in both directions simultaneously. What it means, in the case of full duplex, they both are able to send and receives the data at the same time. Both the devices, they become the sender and receiver at every time. Example of full duplex is the telephone network in which there is a communication between the two persons by a telephone line, which both can talk and listen at the same time. Now, the best or the simple example is cell phones. You can talk on cell phone at the same time. Whenever your friend is talking something, you can you can start talking along with your friend. What it means, at the same time, whenever you are a receiver, same time you become a sender. Whenever you are sender, same time you become a receiver. This can be happened in the case of full duplex. Now this is a diagram. Look at here. This is a system one. Suppose this is a receiver, this is a sender. But look at the direction of the flow. They are sends the data, they are receives the data. At some time it is a receiver, it is a sender, but at the other time it is a receiver, it is a sender. Now look at here, both A and B can send and receive simultaneously. So what it means, both the systems, system A and system B, they both are able to send and receives the data simultaneously at every time. So this can be happened in the case of full duplex. So this is all about the different communication modes. We have the three different communication modes. The first one is half duplex, then the first one is simplex, then half duplex, then full duplex. Clear? This is all about the communication modes.